In one of the earlier videos, we've established that in order for a series to converge, the limit of the sequence must exist, and it has to be equal to 0. Meaning that in order for a series to converge, each individual term must head towards 0. Each individual term must head towards 0. So now we would now make use of this to really understand the series. So most of the time we don't really understand the series. We would make use of this to understand the series. So in order for the series to converge, the limit of this sequence must exist, and it must equal to 0. So if we know that if the limit of this diverge, then we will immediately know that this will diverge. By the way, if it converge, it tells us nothing about the original series. So bear that in mind, because if you look at 1 over n, this thing here will diverge, but the limit is actually heading towards 0, and it exists. So by knowing that it equals 0, it doesn't really tell us anything. All that it tells us, well, if we can detect that the sequence will diverge, or if it does not exist, then we can deduce that this thing here will diverge, and yeah, then we know that this will diverge. So all that we can do is to detect that this heads towards infinity, or if it does not exist. So the minute we can detect these two, then we can deduce that this will diverge. So for example, we don't know anything about this series. So let's look at the sequence. Let's look at the sequence. Now, as n tends to infinity, bear with me. As n tends to infinity, we can see that the sequence is heading towards infinity. So now because it's heading towards infinity, we can deduce that whatever this thing is, it's going to diverge. Okay. So try and detect if we can detect this is heading towards infinity, or if it does not exist, then we can deduce that this thing here must diverge. If it equals 0, then we can't really deduce anything about it. We can't really say much about this thing. Okay, so another example. So hang on. So we are trying to find out if this will converge or if it will diverge. We don't really understand what's going on here. So let's look at the sequence. Let's look at the sequence of this. So now as n tends to infinity, this thing here is the limit will be 1. Well, in order for it to converge, the limit must exist, and it must equal 0. This thing here equals 1. So we can now deduce that this thing here will diverge, because in order for it to be 1 here, if the limit is 1, what's happening here is this. The limit is 1. The limit is 1. So what's happening is that as n tends to infinity, as you add more and more and more terms, you're adding 1 to this thing, you're adding another 1 to this thing, you're adding another 1 to this thing, you're adding another 1. Eventually this thing here is just going to get bigger and bigger and bigger. It's going to diverge. So, well, because the limit is 1 here, you're adding 1 each time to this thing here. So eventually this thing here is going to diverge. Even if the limit is, let's say, 0.004, say, it's still going to diverge. It must equal 0, because as n tends to infinity, you're adding a tiny bit more, and then you're adding another tiny bit more, and then you're adding another tiny bit more, and so on. It's just going to get larger and larger and larger. It's going to head towards infinity. So in order for it to converge, it must equal 0. Here it equals 1, so it's going to diverge. So another example. This thing here, the limit does not exist. It must exist it must exist, and it must head towards 0 in order for this to converge. Here it doesn't exist, so therefore this thing here will diverge. Basically, this thing here is just going to oscillate. Well, anyway, it oscillates, therefore it doesn't converge. So this one here, next one. So we don't know if this series is going to converge. We don't understand anything about this. So let's just look at the sequence. So let's look at the sequence. As n tends to infinity, we've done this many times. You should be able to recognize that it's heading towards negative a third. Well, negative a third. Well, the limit must exist, and it must equal 0 in order for it to converge. Well, this is not 0, so we can deduce that this thing here is going to diverge. Okay.